So, continuing on here with one-to-one functions in Trig in section 3.7, we are on example 4. So, let f of x equal x squared minus 3, but only when x is greater than or equal to 0. So, find the inverse. So, y equals x squared minus 3. So, I'd add 3 to both sides as I'm solving for y. So, I get y plus 3 equals x squared. To get rid of a squared, I square root, so I square root both sides, and I get x equals plus or minus square root of y plus 3, except it says only when x is greater than or equal to 0. That means I want positive numbers, not negative numbers. So I only want the positive one here. I don't want the negative one. So my answer for this is just the square root of y plus 3. So I'm going to take the square root of y plus 3 and plug it in. Let's prove it. Let's make sure that this works. So I plug the positive one in. I take this, I'm plugging the positive one in. Square root of a square cancels out. And 3 minus 3, so I get y equals y. So far, so good. Now I need to take this and plug it in down here, but only to the positive one. Because remember, I only want it when it's positive or equals 0. So I plug that in. Negative 3 plus 3 cancels out. So I have the square root of a square, which is just x. Y equals y, x equals x. So there is an inverse to this, x squared minus 3, but only when it's greater than or equal to 0. Then there is an inverse. So keep that in mind.
Kids, we're going to have to eat this cake by ourselves.
So example 5, find the inverse of x cubed. So I want you to graph it and find the inverse. Once again, just use a graphing calculator. Honestly, just plug in x caret sine 3 graph, go to second graph, and see what the graph looks like. You'll get your points. Here are some points. So we go and graph it. Now, to solve for y, you have to cube root. So to cube root, you end up getting the cube root of y equals x. So there's your other graph. So to find those points, basically, you would just plug in values for y and see what you would get for x is the point here. But what you realize, if you look at the points, because, here's a list of points, if you plugged in, x or, y here to see what you would get, if you plug it in, you see your answers. But look, they're just opposites. Everything just kind of flips around. So the point I'm getting at is if I ever ask you to graph the inverse of a graph is just you flipping the points around. So another point you could tell me would be negative 27, negative 3. That would be an inverse point you could graph. All right, those are inverse points. So something just simple to keep in mind when graphing an inverse, you just kind of flip the points. So I'm going to graph x cubed first. That was negative 2, negative 8, negative 1, 1, 0, 0, 1, 1, 2, 8. And then look at negative 8, negative 2 is right there. Negative 1, negative 1, 0, 0, 1, 1, and 8, 2. Notice how the graph looks identical. It's flipped over the line y equals x. That's what an inverse is. The inverse flips it over the line y equals x. If you have any questions or concerns, the hardest part in this whole section was when you have something that's one-to-one, proving it. Finding the inverse for me is not hard. Just solve for the other variable. Solve for x. There's your inverse. But proving that it is the hard part. And remember, you have to plug in your inverse to the original and your original into the inverse to prove that it works. So if you have any questions or concerns, please let me know. And I will talk with you guys later.